This one is going to introduce the topic of projectile motion. There's not going to be really much math here. I mean, I'm going to show you the equations and you can get them written down. But you're going to have a few of these in your homework. And dude, you're going to deal with this in physics or calculus. Either one. This is real common. There's so many applications to the idea of projectile motion. So let's kind of just jump right into it. So projectile motion. I got this thing, and let's ignore those formulas there. All right. Projectile motion. I got a little XY graph. But notice I just have the positive X's and the positive Y's for this one. Let's just kind of think everything's either non-negative. Let's go that way. So we're no negatives at first. And projectile motion, let's give you some examples. Maybe a soccer player kicks a ball up into the air from the ground. You know what I mean? Kicks a ball. Now, will it just continue to keep going up into the air? It just goes off forever. Probably not. You know what I mean? There's this little thing called gravity. This little thing called gravity, which is going to be like nobody. And it's going to come down and hit the ground. And of course, it'll go doom, 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 doom. But we don't care about that part. We're just looking at, we just want to see where the ball lands. Okay. And it looks like that's kind of like almost looks like a parabola, huh? So the only force that's stopping it, there's nothing from stopping it going this direction when you kick a ball, except for maybe wind resistance, but we're going to ignore all that crap. We'll ignore wind resistance and centripetal force and things like that. We're only going to think about that there's one other thing acting upon it, and that's gravity, which is pushing it down, right? Or, I don't know, I'm misspeaking when I say that, but gravity, that force, is pushing the ball back down to the ground. Cool. So there's going to be a formula, because the thing is, when you kick a ball or you throw a ball or you do anything like that, there's a vertical component and there's a horizontal component. You remember vectors? How we broke it down into a vertical and a horizontal component? Well, we can do the same thing here, except that horizontal component is just X and the vertical component is Y. Go back to it. So here's the soccer player. So they kick the ball. And when they kick the ball, there has to be some initial angle, right? What's the lift? What's the trajectory angle? Oh, man, I'm misspeaking. Remember, physics, I'm talking out my ass here. I know the math. So there's an angle in which it was kicked or thrown or shot or however you want to look at this. Maybe you like firecrackers or something like that. Maybe like rockets. So there's an angle, but there's also something called V naught. That's saying at time equals 0, right when you start. That little subscript of the 0, don't stress about that. That's just saying right when you start. This is called our initial velocity. All right, so there has to be some initial velocity in which the ball is kicked. Maybe it's a football player throwing a ball. Cool, so, right, and the ball would go this way, right? It has some sort of orientation. So I hope you see that we're about to do parametric here since we're in parametric. So it's all going to be some function of time. So when you kick the ball, wouldn't how far it goes horizontally before, like, isn't that going to be some function of time? It's height. Won't it change as time changes? Of course. So here's going to be our formulas. But actually, hold it. That's just one example. Wait a second. What about this? What about, hey, what about somebody standing up on top of a cliff and then they maybe they're playing golf and they're up on top of something and they go and they hit it. Sorry about my graph looking so bad. And of course we'll go, but we're going to ignore all that piece and go, oh look, we still have the same idea. We'd have some sort of angle in which it was hit. Let me get rid of that H. Put it over here. It would still have an initial velocity. The only thing is we would have some initial height. So the height could be up and down, right? But we're still thinking about when's it going to hit the ground. Don't. So here's our formulas. And there's two of them, right? We got to have an X and we got to have a Y. And there's a lot to talk about, but if we have this down where we have V naught's our initial velocity, we got that h is our initial height, and theta is our, maybe it's called our launch angle. We're basically just going to need to start plugging things in. All right, so a lot of the games end up being, hey, V naught's equal to this, theta's equal to, say, 30, and your height's equal to 0. Go graph it. But you're going to have to start by plugging all these values in and solving. So once you get this formula up here, this is merely going to look, once you plug numbers in, is that you're going to get x is equal to some number times t. So I'll just put an example. Maybe it's 5 times t. Of course, I'm not giving you a problem. It's not a question. The 5 came out of nowhere. I'm just saying it's just a number. That V naught times cosine of theta, that's just a number. And then we're going to have our y is equal to negative 16t squared plus V naught sine theta times t plus the initial height. And what that's saying, unfortunately, is we're in the British imperial system. But I'm getting ahead of myself. So possibly this could look like this. Maybe I'm just going to put in a number for V naught times sine of theta. Maybe this one's going to be 32 times some t. And maybe the height this time was, you started at 64 feet up in the air. Yeah. So it looked like that. So I think that looks like a parabola with a negative, right? And I can tell it's a parabola because of the square. And I can tell it's facing down because of the negative. So it's saying if you had like a parabola that's facing down, that would say that whatever comes up must come down due to gravity, right? We would have to come down. An upside down parabola is your y value, saying gravity must be acting upon it. And again, what goes up, it must come down. So we do have ourselves an upside down parabola. But that's an upside down parabola with respect to time. All right, the last couple of things just to talk about, I got to cover my ass on some stuff, and I spoke on it, this is in the British imperial system. This means if you were looking at a formula like this, that your height is in feet and your time is in seconds. Your text is jumping over some stuff, which makes me very, very, very cranky, and it just uses this negative 16t squared, which is cute. This is for the British imperial system when we're talking about feet. If you are a STEM student, you're going to need to get away from the idea of frickin' feet. Feet suck. No. We use the metric system typically. This is just a good way to introduce you to it because you end up with a negative 16. If we were in the metric system, which you're not going to deal with, but I don't want you to not see it, your y value would change. It would actually be negative 4.9 t squared plus our V naught sine of theta times t plus our initial height. The force of gravity, and that's what your textbook leaves out. It doesn't talk about that this has to do with gravity. Your negative 32 feet per second squared if you're in the British imperial system. Negative 32 feet per second squared is your acceleration due to gravity when you're in the British imperial system, versus your gravity would actually be negative 9.8 meters per second squared if you were in the metric system. So your text is not going to use this, so we don't have to look at it for now, but know that it will be coming back. Your STEM classes don't typically talk about feet. That's some bullshit we use in simple algebra classes and introducing you to topics because they're nice clean numbers in the British imperial system at first. The metric system works so much better and we need to get used to it. So there's an intro. Sorry it was so long with not much problems, but hopefully you kind of grasp something on it. And the next one, we're going to go through a long ass problem. I'm going to do it a little differently than maybe the way the textbook shows you, or your homework where it just asks you to look at a graphing utility. I'm going to do everything by hand and solve through an entire problem. So I will see you in the next one with an example.